All right, hello everyone. My name is Mete Atamel. I'm a developer advocate at Google. I'm based in London, and this is my first time in Krakow. It's a nice city. Unfortunately, I came in last night, and I had to leave this afternoon, so I don't have that much time to see the city, but hopefully next time I can stay longer, because it seems really nice. And today we're going to talk about gRPC. Before I start my talk, this is my Twitter, so if you want the slides, just follow me, and I'll post the slides right after the talk. And this is my email. I'm going to be around after my talk, but if you have any questions about gRPC or Google Cloud in general, feel free to reach out to me from my email as well. And the last thing is I have a feedback link for my talk, bit.ly/Atamel. If you like my talk or if you don't like my talk, just send me some feedback because I'm always looking forward for feedback. The first 5 people can get these gRPC t-shirts. So once you fill it, come over and I'll give you a t-shirt. And for the rest of the people, I have stickers for gRPC, so feel free to stop by. So what am I going to talk about? Actually, I gave this talk in Germany like a couple of months ago, I guess, and then some girl, Joy, she took a note on a single page, and it's really good, actually. It covers everything that I'm going to talk about. So that's it, but I just want to share it because I really like these notes. But in terms of what I'm going to talk about in more structure, first I want to do like a little introduction. So what is RPC, and what's the motivation for gRPC? So we're all on the same page on why we even have gRPC in the first place. Then I'm going to cover the basics of gRPC. So what is it? What are the design goals? And what is it trying to solve? Then we're going to look at some code, hello world gRPC in Java. And then after that, we'll look at the benefits of gRPC. So HTTP2, protocol buffers, multi-language support, connection options. So we'll just talk through those. And then finally, we'll look at some more code in gRPC, which is a streaming chat sample. We're going to use Java and .NET. I guess most people here are Java, right? Yeah. Are there .NET people as well? A few? Oh, good. So we'll see that gRPC actually works across different languages. So it doesn't really I mean, everything I talk about here, it applies to multiple languages. So it's not just for Java or .NET. So that's the agenda. We should have some time at the end for question and answer. But if not, I'm going to be around. So feel free to reach out. All right. So let's do an intro first. So before we talk about remote procedure calls, let's look at the regular procedure calls. I mean, everyone knows this, but I just want to cover it briefly. So let's say you have a greeter service that has a simple, I misspelled greeting, that has a simple greeting method that takes in a string and returns a string. And then you want to call this service from some other class. What do? Let's call it a greeter client. You create a service. In .NET, we have this awesome thing called var, so it makes it really nice and concise. In Java, you would have greeter service here. And then you just call your method directly. Everything, like in Java, in JVM, everything is in the same JVM. Same machine, so it's very simple, and that's what we do normally. But when you look at remote procedure calls, this is a definition from Wikipedia. I'm not going to read it all. But the key thing in RPC is that you have 2 pieces of your program that are separated by some kind of network, and you want one piece to call the other piece, but you want it to happen in such a way that it feels like a local call, right? That's the whole thing about RPC, is that even though it's remote, so you're making a remote call to a remote server, you want it to look like a local call. You don't want the client to actually feel like it's making a call to a remote server. So that's the whole thing about RPC, and I think that's what this whole thing is like trying to capture. So it kind of looks like this now. So you have your greeter service living on some server, and then you have your client. It can live on a desktop or a mobile or a laptop, and they're separated by some kind of network. So that's how it looks like. But then at this point, you have a few questions to answer and figure out. The first thing is, how do your clients call the service? Do they make an HTTP call? Do they make a TCP connection? What does that look like? Because they're not on the same machine, same JVM anymore, so you need to think about the connection. The second thing is, how does the server expose the service, right? So we have this greeter service, and do you want to expose the whole every method on that service, or do you want to expose the public methods? Or do you want to expose all the public methods, or do you want to expose some of the public methods? And if so, how do you mark them as like exposed to the outside world? So it's something that you have to worry about. So you're making a call from the client to the server. It has to go over the wire. So you need to basically convert everything to bits and bytes. So you need to serialize things and deserialize them on the other end. How do you do that? Do you use XML? Do you use JSON? Do you use binary? It doesn't matter. So these are some things that you need to worry. And what about the connection itself? I mean, do you make a connection to the server and get a reply, or do you keep the connection? Is it like a streaming connection, or is it like two-way connection? So it's something to worry about as well. And finally, authentication. You probably don't want your service to be called by anyone, so you need to have some kind of authentication. So all these questions, they become important now because you separated your client and the server, and they live in different places, so you need to think about these things. So the choice you have at this point is basically you can build your own RPC framework and try to answer these questions and implement them. So the plus of this scenario is that if you build your own RPC framework, you can do it exactly how you like it for your own use case. And I actually did this when I was working at Adobe. I don't know if people remember Adobe Flex. Has anyone worked on Adobe Flex? A few people. OK, good. So I'll talk about more on the next slide. But basically, we had this thing called Adobe Flex Data Services, which was kind of like an RPC framework, and we built it from scratch. So it was perfect for me because we built it exactly how we like it, and it was perfect. But the drawback on this case is that you need to answer all these questions that we asked earlier, and you need to find answers, and you need to implement them yourself. So it takes a lot of time and effort to actually find the answers and implement them yourself. And the second choice you have is use something like gRPC. So gRPC, it's like it's high-performance open-source universal RPC framework. It's open source, it's in the community, and the pluses of this is that all the questions that we ask, people already answered them, and people already implemented them, so you can just rely on the community for these questions. The only drawback for RPC, for me at least, is that gRPC comes with some flavor of code. So for example, in Java, you need to have builders, and you need to get something from the builder for everything. So it's kind of verbose, and also if you look at the generated code by gRPC, it's not the most beautiful code to read. So you need to actually buy into that gRPC style. So it's a choice that you need to make. If you're happy with that code, then you can use it. Otherwise, if you don't want to use it, you have to build it yourself. All right. So on this question of building your own RPC framework, so back in the day, I used to work at Adobe, and there was Flash, and the Flash was on every single device you could think of. The problem with the Flash was that it was mainly used for games, and what Adobe wanted to do is that they wanted Flash to be used for applications as well. So they created something called Adobe Flex. It's a framework. It's kind of like Angular. You could think of like Angular, but it's for Flash applications. And the idea was they created this notion of rich internet applications. So you use Flex to create this rich internet applications that could do much more than what HTML and JavaScript could do back in the day. So to connect those Flash and Flex clients, we created to Java backends, we created something called Flex Data Services. And then what we did is basically we had a remoting service that would get like a Flash object, in this case an ActionScript object. It will serialize it using something called AMF, which is a serialization format of Flash, and it will send it to the server. On the server, we wrote deserializers to deserialize that Flash objects into Java objects, and we'll find out where it needs to go, and then we'll route it through some message broker to Java classes. And on top of remoting, we created something called managed remoting, and there was data management service, and there's like messaging service. And then we created all these channels. So for different kinds of connections, we created like HTTP channel that was like regular HTTP. We created HTTP polling for to poll the server once in a while. We created HTTP long polling, where you poll and wait for a response. We created HTTP streaming, where you have a connection open from server to client. We created WebSockets when they came along. And then there was also an RTMP channel for the socket-based protocol in Flash. So we spent a few years to build this, and it was great, and it was working for Flash. And we created a version of Flex was called Air. It was for desktop applications. So we connected those as well to our service. Then at some point, we even wrote like Java clients and HTML5 clients as well. So everything was working, and it was great, and we felt really good about building our own RPC framework. But then this came along. So in April 2010, Steve Jobs came up with this letter called Thoughts on Flash, and you can actually read it, it's still online. And he basically explained why Flash will never, ever be on any iPhone devices. And it was semi-technical, so somehow some of his arguments were technical and they were quite right. And some of them were, I think, more political than technical. But basically, this was really bad timing for us because this was a time when we were trying to push Flash on everywhere on mobile devices. And then when he came up with this, it's like the #1 platform for mobile apps. And he said that Flash would never be there. It basically killed Flash. So after a few months, Adobe gave up on Flash and they started focusing on JavaScript and HTML. And my team got assigned to different things, and we started working on completely different stuff. So our Flex Data services, we tried to open source it as Blaze DS. I don't know if you guys heard it, but it didn't go anywhere because it was mainly geared for Flash, and it wasn't truly open source per se because it was owned by Adobe, and there was no open source contributors, stuff like that. So the whole thing basically died, and it was kind of sad for me because you spend all this time and effort to solve problems that apply everywhere, but it's not open source, and it didn't apply in the general case, and then it went away, and then I switched jobs, and I went to a new place, and I still had the same problems, but I couldn't use our framework. So that kind of taught me the lesson of, make sure you rely on things that are kind of open source and supported by the community, because you don't want to rely on one company or one thing, because you never know what's going to happen. So that's my thought on building your own framework. Think about it. Make sure that you really want to do that for a really good reason. OK, before I start talking about gRPC, I want to talk about REST, because people ask me, why do we even need RPC or gRPC? Why can I not use REST? And my answer to that is that if you can use REST, go ahead and use it, because we understand REST, we understand get and post and put and delete. And we understand the semantics of it. So if it's good for you and it makes sense, use it. I think RPC kind of makes sense for more complex services. For example, if you think of like a bank transfer scenario where you need to take transfer some money from one account to another account, you can probably do that with REST, with multiple REST calls, but then you probably need to do calls and check that they succeed, and then if they succeed, then go to the next call. So there's a lot of things that you need to do to make sure that transfer happens correctly. Whereas if you use something like gRPC, you can actually create a bank service, and you can have like methods on that says transfer from this account to this account with this amount, and abstract away all the complexity within this call itself. And also RPC itself, it allows you to write more strongly type experience, so you can have stubs on the client and stubs on the server. So with that, you are dealing with objects. You're dealing with bank service, and you're passing messages to that bank service. So that way, you have IntelliSense, and you know exactly what you're calling and what the methods are. So it's much better than just making HTTP calls, because when you make HTTP calls, like you have to know what the format is, all that kind of stuff. Whereas with gRPC, and I'm going to show you some code, everything is very strongly typed, and you can actually know what you're calling and what the parameters should be. And finally, the efficiency that comes with gRPC. gRPC is based on HTTP2 that we'll talk about. It's based on protocol buffer in Java world, and it can also be based on Bond in .NET world. So a lot of efficiency is being built into gRPC. So by just using it, you get that efficiency for free. But the moral of the story is, if you want to use REST and it works for you, use it. But then if you feel like you're struggling with REST, you want something more efficient and more strongly typed, then that's when RPC frameworks like gRPC make sense. All right, so now let's talk about gRPC basics. So gRPC, it actually doesn't stand for Google RPC. That's what most people think. It stands for gRPC Remote Procedure Call, so it's a recursive definition. It's open source, general purpose, standards-driven RPC framework. I have to underline high performance because it is very important at Google that we are as efficient as possible. And gRPC came from something called Stubby. Stubby is an internal RPC system used in Google. And engineers who worked on Stubby for years, they basically looked at it, they learned from it, and they created gRPC for the open source world. But efficiency is very important, and high performance is really important, and you will see that in gRPC in many places. And it's now open source and contributed by a number of people. The current version is 1.3.4, the last time I checked. But a new release, it comes up quite often, actually. All right, there's some motivation and design principles of gRPC. If you go to this link, you can read all about them in more detail. I'm not going to go through them all, but I just want to point out a few things. The first thing is gRPC is free and open. That's very important, as I mentioned. The second thing is it's performant, so we try to make it as highly efficient and performant as possible, and I'll show you some examples of that. And the third thing is when you're building distributed systems, people sometimes forget that things are distributed, and they make calls thinking that they're local, even though the call you're making is not local, it's remote. So in gRPC, they basically want to avoid this notion of, they don't want people to forget that it's a distributed system, so they have services, not objects, and then messages and not references. So everything you build in gRPC is a service, and then you pass messages to the service, and you get a reply from the service. This way, we are trying to avoid the case where people think that it's objects and you're just calling a method on the object. That way you're thinking about messages and services, and it's distributed. And we'll see some code examples of that. And then there's a bunch of other things like blocking and non-blocking and cancellations. It's actually payload agnostic, so it's based on protobuf, but you can actually change it to something else like bond or something else. But you can read more about it on this page if you're interested. So how does it work? At the very high level, you first start with a service definition. So the service definition, it's a protocol buffer file, basically, that defines what your services are and what the methods are in your service, and then what the messages are. So I really like this because normally when you are looking at some code base, you're kind of lost. Like you don't know what the main classes are, you don't know what the main methods are. But with gRPC, all you have to look at is this main service definition file. And from there, you can get a high-level sense of what your services are, what your methods are, and what the messages are being exchanged. And we'll take a look at that first. So once you have the service definition, you generate code. So you generate code for the client, and you generate code for the server. So all the low-level connectivity between the client and the server, it's handled for you automatically. You just create your service definition, and then generate code, and then you have the connectivity ready to go. And this code generation, it happens in 10+ languages. I'm going to show you today Java and .NET, but there's others as well. And then once you have that, so you have the client and the server, and they're connected with the stubs. You get efficiency with serialization with protobufs. So by default, gRPC uses protobufs. And then you'll have connection efficiency with HTTP2. And we'll take a look at in detail of what the connection efficiencies are for HTTP2. And then you also have some connection options. So if you want to just make a request and get a reply, that regular HTTP, you can have unary connections. If you want to do server-side streaming, so you have a connection open, and the server just streams a lot of data. For example, for like a financial stock application, you have server-side streaming. If you want the client to stream data, you have client-side streaming. And then if you want to have bidirectional streaming, where the client and the server can send data at any time, you can have that as well. Actually, the last example I'm going to show you is going to be bidirectional streaming. We're going to build a chat application where the client and the server, they can send messages to each other at any time. And then you also have authentication options. So SSL, TLS, token-based, stuff like that. You have that available. And you can also plug in any kind of authentication you want. Everything is very pluggable. All right, so at the high level, let's say you have a Java service. And then you generate the gRPC service from the service definition. Then you can have clients. So you can have a mobile client and a laptop client. They also have stubs that are generated from the service definition. And the service and the stub, they talk to each other with generated code, so you don't have to worry about that. Then you can have another service. Let's say it's a Python service, so the Java service can call that. And they're, again, talking through the stubs. And then you can have more services, like a Golang service or a C++ service. I like this because, as you can see, you can pick and choose whatever language you want, and everything is handled through the stubs, through the generated code, so you don't have to worry about that. So if you have teams that work on different kind of languages, they can still do that. All they need to agree on is the service definition file, and then from there you can generate all the code you need to talk to each other. All right, so let's look at the code now. So it's basically 4 steps that you need to do when you write gRPC code. The first thing is, as I mentioned multiple times now, the service definition file. So let's say we want to build this hello world application that I showed earlier. First, you need to create a greeter.proto. This is a service definition file that will define our service. So the first thing is we say that this is a service. Remember, in gRPC, everything is a service. So we don't want to think of them as objects, but services. And then I create a method called greeting. It's an RPC method. And then it takes in a hello request message, and then it returns a hello response message, right? So this is a very simple service. But this hello request service and hello response service message, we need to define what they are. So I define my message, and I say this is a hello request, and it has a string name. So it only has basically a string in the message itself. But these messages can be as complicated as you want them to be. They don't have to be just one thing. They can be complex objects, and I'm actually going to show you an example of that. And the response is also just a string. So I'm basically wrapping my strings into messages. So you define this. And then the next step is to create the client and the server stubs so that they can talk to each other. So if you are a Java person, you can use a Maven plugin or a Gradle plugin to basically generate the code that you need. For .NET, there's a NuGet package for gRPC. This version number is probably out of date now, but basically if you search for gRPC tools, you'll see it. And then there's also a proto. So this comes with a proto-C file, and from there you can call this service definition and it generates the code for you. So now you have the generated code. You need to create the server. So for server, it's basically first you need to create a service implementation. So the implementation is what you have to actually define. So what happens when the greeting method gets called? What you need to do is you create a class that extends from the generated code, and then you override a method, and then you define what happens. And then from there, you just create a server with the ports and the implementation, and you just start the server. And we'll take a look at this shortly. The client side is a little bit more complicated, so you need to define how the client talks to the server. So for that, first you need to define what's called a channel. So gRPC also has this notion of channels. We used to also have them in Flex data services. So the channel basically defines the nature of connection that you have to the server. Once you define the channel, you also need to make another choice. You want to figure out basically whether your stub is blocking or non-blocking. So in blocking, you make a call to the server, and it blocks until it gets a response. In non-blocking, you basically have a callback that gets called when you need it to get called. In the first example, I'll show you a blocking example, but then in the chat example, I'll show you a non-blocking one. But you have a choice on how you want to get messages, basically. And then you create a request, you send the request, and then you handle the responses either synchronously or asynchronously. So let's just take a look at some Java code to see how this works. By the way, all of this code is under my GitHub, so if you just go under my name and then gRPC samples Java, then you'll get these. I also have the same samples in .NET, so it's under gRPC samples -.NET, and I'm going to provide a link of that shortly as well. All right. So here I am in Eclipse, and then I have 2 projects, Greeter Server and Greeter Client. The first thing that I want you to take a look at is this Greeter Proto. So this is the service definition file I was talking about. So we are using Proto 3. So Proto buffs, they have like different versions, but we are using the latest one, Proto 3. And then I'm saying Java multiple files true. This means that when you generate code, make sure that the classes are separate. They're not in a single file. And then the main thing is this service here. So this service is what I showed you before. It's a greeting service that takes in a hello request and returns a hello response. And the request in this case it's a little bit more complicated. So here I have the request has the name, but then I also have the age of the person, and I have the what's called repeated. So repeated is like it's a list in gRPC. So this is the hobbies of the person, and then I also have a map of the bag of tricks of the person. So you can have, gRPC has its own types basically. It's the main types like the string, ints, and dates, and maps, and lists. So I'm just listing some of those here. And then I also have a sentiment. So this is an enum that I define. So this sentiment I define up here. So the person is either happy, sleepy, or angry. So this is my request, and then the response is just a greeting. So it's just a string. So once I have this Greeter Pro, what I can do is in pom.xml, I already have the plugin. So this is the protobuf Maven plugin. So with this, I basically just point my Greeter Pro. So if I do Maven build, it will just look at that, and it will generate the code. So if you look at under target generator sources, you'll see that there's a lot of code here. So this code basically defines the service, defines the request, defines the greeter object, defines the response. And as I mentioned, gRPC uses builders in Java, so you have builders for everything as well. I usually don't look at this code, because if you look, let's just take a look. It's not that pretty, actually. See, it's the typical generated code that I don't really look, because with IntelliSense, I know what to call, so I don't actually have to look at the details of the call itself. So this is a server, and what we need to do is first, we need to create the server. So what I do is I create a greeter server. And the first thing is you basically, from the server builder, you define which port you want to use, and then you add a service to that. In gRPC, everything is a service. So in this case, we have a service. This greeting service implementation is something that I'm going to provide. So I'm going to define what's going to happen. So we'll take a look at that. So I create my server, I add my service, and I do a build to get my server. And then after that, I start my server, and that's it. So I just basically, it's just adding a service that I define, and then starting my server. So if you look at this guy, this is kind of like the main thing in gRPC. I define this greeting service implementation. It extends from this base class. So this is generated code that's given to me from gRPC. And then from here, I get a method called greeting. And I overwrite that and define what's going to happen. So I get a request, and then I have a response observer. So this is my response to the client, basically. So what I'm doing right now is that I'm basically just printing the request. And then from the request, as I mentioned, everything in gRPC is strongly typed. So from request, I can actually see what's in the request itself. So if I do request dot, you can see that I can see get age, get better tricks, get name, stuff like that. So that's nice. So from the request, I get the name, and then I do a greeting, hello there, the name of the person. And now I need to create a response. So what I do is I have a hello response builder. So I get a builder. And then from there, I set the greeting. And again, it's strongly typed, so I know that there's a greeting. And I pass in my greeting, and I do build to get my response. And then all I have to do is on response observer, call on next. So I'm passing my response to the client, and I make sure that the client gets that by calling on completed. So I'm just saying that, okay, this is my response. Make sure you flash it so it gets to the client. So all I'm doing is getting a request, getting the name of the person, creating a greeting, and passing it back to the client. So that's server. If you look at the client itself, so there's a greeter client that I created. As I mentioned, first you need to create the channel, the connection to the server. So what I'm doing here is I'm, again, using the channel builder, and then passing the host and the port. And then I'm saying use plain text true. So this says that don't use HTTPS, use plain text. And then I do a build to get a channel. Now, from the channel, I need to get a stub. So stub is what I use to talk to the server. But I want this stub to be blocking. So when I make a call to the server, I want it to block. So I, again, use this generated class and say new blocking stub. So give me a blocking stub, and I pass in my channel. And from the stub, first I need to create a request. So again, I get my hello request and the builder. I set my name, my age, my sentiment, and do a build, and then get a request. And then finally, I use a stub. And then stub is, again, strongly typed. So I know that there is a greeting method, so I pass in my request. And then since it's blocking, I will get a response. And then from the response, I get my greeting. So that's all there is to it. Let's just run this quickly to show you that it actually works. So I can start my server. I don't think I changed anything. I had to stop it. 1 sec. All right, start that. All right. So server started, and then if I do client started, then client sending request, and then I get a response. It's very simple, but it gives you an idea on how things work in gRPC. So let me just stop the server before I forget. All right. So now that we know how things work, so let's look at some of the benefits of gRPC. So if you want to use it, what do you get from gRPC? So the main benefits is first HTTP2, and we'll talk about that. What are the benefits of that? The second thing is efficient serialization. So by using protocol buffers, you get a lot of efficiency. Same thing with Bond in the .NET world. The third thing is multi-language support. So as I mentioned, you get 10 plus languages for free by using gRPC. And the last thing is connection options. So you have all these different kinds of connections that you get by using gRPC. So these are kind of, in my mind, the main benefits of using gRPC. So let's talk about HTTP2 now. If you look at the history of HTTP, it's kind of amazing, actually, because first it started with HTTP 0.9, and then we had HTTP 1 briefly, and then we had HTTP 1.1 from 1998 till almost today. And if you look at technology, I don't know, like not many things last that long. So in that respect, I think HTTP 1.1 is quite successful. But there are some limitations of HTTP 1.1. One of those limitations is that for every HTTP connection, you need a new TCP connection. So that means that the number of HTTP requests you can have in parallel is limited by the number of TCP connections that you can have. So that kind of limits the parallelism in HTTP 1.0 and 1.1. So what you do in HTTP 1.0 is that you make a request, and then you wait for a response. And then once you get a response, you can make another request, and then you get another response. This is without pipelining, so there was no pipelining in HTTP 1.0. So this was very simple to think about, but at the same time, it was very limited because you had to wait for the responses to come back before you can make any requests. Now, in HTTP 1.1, we introduced pipelining. So in pipelining, the idea is that you send requests without having to wait for the responses. So it kind of looks like this. So you send multiple requests. But then the problem is the responses, they still have to come back in the same order. So what you end up having is that if this response is delayed for some reason, then you have to delay all other responses. So even though you can send multiple requests, your responses are still delayed. So it kind of helped a little bit in sending the responses, but it didn't help with getting the responses. So it's not that useful if you think about it. And then there was also a lot of overhead in HTTP 1.0 and 1.1. For example, headers, they were uncompressed, they were plain text, and we were sending them in every single request, even though not much changed between different requests. So we recognized all of these limitations of HTTP 1.1, and Google started working on something called Speedy around 2009, something like that. And then Speedy basically turned into HTTP 2. So at some point, people working on Speedy and other people, they came together and they decided that they should standardize all of that, and that's how HTTP 2 came along, basically. So the idea of HTTP 2 is that it's trying to address all these problems that I talked about, so the end user latency, the header line blocking, having multiple connections, and then the overhead, the protocol overhead. They're trying to address all of that in HTTP 2, but they're trying to do it in a way that that's not going to replace HTTP 1.1, but rather extend it and make it better. And we'll look at how that happens. So the idea in HTTP 2 is that in HTTP 1.x, you have the headers and the message. They're like in one payload. But in HTTP 2, they basically broke that into what called frames. So you have a headers frame and you have data frame, and these can be sent separately. So that way, you have like smaller chunks that you can send back and forth. And this framing is binary, so it's not text-based, so it's much more efficient. You have a single TCP connection, which is huge. So instead of creating connections and getting rid of connections all the time, you can have a single connection. There's no header line blocking. There's no notion of requests anymore. There's the notion of streams, and we'll take a look at that. And the headers are compressed. So the headers, not only binary, but they're also compressed, so it's much more efficient than HTTP 1. So in HTTP 2, there's this notion of streams and messages and frames. So frame is like the smallest unit that you can send, and then the collection of frames is called messages, and the collection of messages is called streams, and then you can have multiple streams going back and forth on the same connection. So if you take a look at it like this, you can have a client, And then you have a server. There's a single TCP connection. That's the important part. And then you have multiple streams going back and forth between client and the server. So in this first stream, you have the headers frame, and then you have the data frame. But then in between, you have other streams. You have stream 2, you have stream 3, and nothing is blocked. Nothing is waiting for each other. Everything is like chunked and sent separately. So there's no header line blocking. There's no multiple connections to worry about. So everything just happens over a single connection, and you can have multiple streams over that. And then the header compression in HTTP2 is kind of interesting. So if you look at how you send requests in HTTP1, let's say you have this request, a GET request to some resource, and then in HTTP2, you also do the same thing. You have a headers frame that will have pretty much the same information, but then what happens in the next request is where the HTTP2 is different. So in HTTP1, you would basically send the same request, even though everything is pretty much the same, except the path is different. So if you look at this, everything is exactly the same except the path. But in HTTP 1.1, you would send the whole thing. Whereas in HTTP 2, you have a headers frame that will just send what's different. So it will, the client and the server, they basically keep track of like the list of headers that's been exchanged. And with that, they can send what's different rather than sending everything every single time. And then this stuff is compressed further. So even though, so it's much smaller than what it used to be, and on top of it, it's compressed. So you can see the efficiency here. So what this means for you is that basically images load like this rather than like that. And there's actually a good site, HTTP2 demo. We can see if it works. We can actually see HTTP2 HTTP2 in action there. So in here, you can load an image in HTTP1 versus HTTP2. So this image, let's do a refresh. So it loaded in 1 point whatever seconds, and then if you run this in HTTP2, then it's like 0.6 seconds. So usually it's faster. Let's see, let's try again. So 1.2, and 0.2. So it means that things load much faster and much more efficient. All right, so that's HTTP2. The other benefit you have with gRPC is the protocol buffers, the serialization format. So for that, I just want to point you to one place where we actually switch from JSON and HTTP to gRPC protocol buffers and see what happened. So in Google Cloud, we have a service called PubSub. It's a publish subscribe messaging framework. And it used to have a JSON HTTP endpoint. It still does. But we also created a gRPC endpoint for that. And what we seen is that once we switched from HTTP JSON to gRPC, we saw 3x increase in throughput. And the thing is, we got 3x increase, but it only took 1/4 of CPU resources. So you got 3 times throughput, but with 1/4 of the CPU. And that's huge for us because there's a lot of millions of messages that's being exchanged. So if we can even save like 1x or 2x or whatever, like it will really help us. And if you want to read more about this, there's a blog post about this that explains all the details about how this is done. And the last one is the multi-language support. So gRPC is supported on all these languages. And there's more coming, I'm sure, because the community, like they're working on it. So if there's a language that's not here, you can work on it and add it to gRPC. And these are the platforms supported. So you can run gRPC on these platforms. So now I want to show the same greeter server and client in C# and see how that looks like. And again, this code is in grpcsamples-.net if you want to take a look. So here I am in Visual Studio, and I have the same kind of setup here, the greeter client and the greeter server. Let's just briefly take a look at the program. So that's like the main entry point for the .NET applications. So I'm pretty much doing the same thing. So I'm creating a server, and I'm setting the services of that to an implementation that I define, and then I also define the port, and then I set the service, and that's it. And then if you look at the service implementation, it's very much like the Java one, except in C# we have this thing async await and tasks. So I'm basically wrapping my response into a task so that it's asynchronous. So what I'm doing here is I'm basically creating a response. And there's no builders in C#, and I kind of like that because I feel like builders are, they just a lot of code for no really good benefit. So here we don't have builders. So this is response, and I set my greeting, and then return a task from it so people can wait. And if we look at here, basically, so this is the server, but then if you look at the client, again, the same kind of stuff. We create a channel, and then here we are saying that this channel is insecure because it's HTTP. And then I create a client. So we don't have the notion of stubs in C#. We have the notion of clients. So I had the client, and then I create my request, and then I basically use the client, make my call, get a response, and then just print the response. So it's quite similar. And if I run this in console, I can do a greeting server. The server is waiting, and then if I do a greeting client, it makes a call and it gets a response. It's hard to see, but yeah, it works. All right. And then the last thing I want to talk about is the connection options. As I mentioned, we have unary, server-side streaming, client-side streaming, and bidirectional streaming in gRPC. I like this bidirectional streaming quite a lot because that means that you can have a connection open in the client and the server, and anytime anyone can send any messages and it just gets to the other side. So I just want to show you a chat application that uses gRPC streaming. And I want to show this so that I also want to show this in Java and C#, so we will use a Java server and a C# client and a Java client as well, and see that gRPC really works across different languages. So let's just take a look how that looks. So here I am in Eclipse, and what I want to look at is the chat server. First, let's take a look at the proto file, the service definition file. So here I'm defining a chat service, and there's a method called chat that takes in a chat message and returns a chat message from server. So basically, it takes in a message from the client and returns a message from the server. But the key thing here is that I'm marking this message as stream. So this says this is a streaming connection from client to the server. And then I'm also marking this one as stream. So this says it's a streaming connection from server to client. So by marking these messages as streams, I'm creating a bidirectional connection, basically. And my chat message is it's a message that has from, who is sending the message, and the actual message itself. And then the chat message from server, it has a timestamp. I commented that for now. But it's basically, it will take the message from the client and wrap it into a server message and send it back to the other clients. That's what it will do. So from here, I get, let's look at the server. So the chat server is very much like before. I create a server, and I add a service, and I will define what will happen in the service. And then I set my service. That's it. And then if you look at this implementation, again, it's extending from this base class that got generated for me. And the thing that we have here in Java is response observer. So in this chat message, you get a response observer that you respond to. So this is how you talk to the client, basically. So what I do is once I get a request here, I add it to my list of observers. So these are the connected clients that I have. And then I am returning a stream observer that has some methods like onNext, onError, and onCompleted. So this is what happens when I receive a message from the client. And then this is what happens when there's an error, and this is what happens when the client closes the connection. So what I'm doing when I receive a message is that I first print the message, and then I build a server message, and then I wrap my client message into that, and then I call build again to get the actual message. And then I go through my observers, and then I pass my message to the observers. So I'm basically taking the message from a client, wrapping into a server message, and passing it back to the all connected clients. That's all I'm doing here. So that's the server. And then if we look at the client itself, it's a Java FX client. So this Java client, there's a lot of UI code here, but we can ignore all of that. The important part is this. So again, I create a channel for my connection, and then I create a stub. This time, the stub is not blocking. It's a non-blocking stub, because I want the chat service to work at any time. I don't want it to block. So I get a chat service. And then from here, I call the chat method that gives me this object. It's a stream observer. And it's the same thing, basically. This stream observer basically defines my connection to the server. So when I get a message from the server, this will get called on next. And then when I get an array, this will get called, and so on and so forth. So what I'm doing is that when I get a message, I basically just get the message and display it in my UI. That's all. And then there's also a button. So when I hit that button, when I type a text and hit the button, I create a chat message. So it's the same thing. Again, I use this chat message new builder and set from and message. Everything is strongly typed. And then from there, I just call on next on this chat object and pass in my message, and that gets sent to the server. So that's the client and the server. And if you look at C# code, actually, I have this chat Windows client, and this is a Windows form. So what happens in here is that, again, you create a channel like Java, and then from there you get a client, a chat client, and then what you do is when the form loads, you call this chat method, and then you get a call, and then from the call you have something like there's a response stream attached to the call. So you get the response stream, and then you basically just loop over it. So this basically, there is this async await thing in C#. It's non-blocking. So you basically loop over it, but you don't block. And then so every time you have a new message, you'll drop in here, you get the message, and then you just display that message, and that's it. And you just keep looping. But this is not blocking. That's the beauty of .NET and C#. So let's just run this quickly. So I'll start the server. So the server is running on port 880, and then I'm going to run the client. So this is a JavaFX client, and then let's run this .NET client as well. So I'll just put them side by side. I call this C# client, and then let's call this Java client. And this says, Java rocks. So let's see what happens. If I hit send, everyone gets it right away because it's streaming connection, and then this says C# rocks. There you go. It just works because of gRPC streaming. All right. So we're almost done. What I want to point out is that there's actually a Google Developer Days here in Krakow in September. It's about Developer Day for Google-related technologies. So if you're interested, just sign up here for your interests, and then you'll get more information about it. I just want to point that out because we're in Krakow. And yeah, that's all I have. So if you want to know more about gRPC, this is the link. If you want to get the slides, this is my Twitter. If you fill the feedback link, I have t-shirts, so stop by. And if you want stickers, they're here. Thanks very much. And I think we have a few minutes if you have any questions. Anyone has any questions? Yep.
Yes, I would like to ask you how much is it fault tolerant? What if the server, the service I'm calling will go down, and there is some, I don't know, HA proxy which will like reconnect, or how it works?
Well, you have callbacks for things when it fails, so you'll get a callback that it failed. It's not going to, I don't think it retries or something. Yeah. So you'll get a callback, and you have to retry. Any other questions? Yep.
Is there some integration with Spring Boot?
I heard that there's some kind of integration, but I haven't looked into it, so I don't know what the details are. But I think there's something, yeah. Yep.
How do you ensure that all clients and the server have the same service definition? And how do you manage different versions across different environments?
So, I mean, you check in your version or service definition to GitHub, and you generate things from there. But if something needs to change, it's usually OK to add stuff on top. So let's say you change the message, and you want to add more fields. It's usually OK, because in gRPC, it will ignore things that it doesn't know about. So if you have an older client that doesn't know about this new message, it will ignore things. But if you remove things, or if you change the names of things, or if you remove the order of the things or something like that, then it's going to break stuff. So you need to think about that. So whatever you do today for backwards compatibility, you need to do the same stuff for gRPC. Any other questions?
Is it possible somewhere just leverage also the approach of using the queues? Because in the queue you also most of the cases when you use queue you have a load balancing stuff. Most of the cases that you use, and then in the queue you just put those messages that you'd like to send through.
Yep.
So is it possible just to combine the gRPC with some kind of queues like Rabbit or Kafka? Because
Well, I mean, it should be possible. I don't think there's anything like ready where you can just plug it in, but it should be pluggable somewhere. When you send the messages, instead of sending to the server, you send it to a queue or something like that, and then the server somehow pulls it from the queue. So you need to write that yourself. There's nothing ready for you today, as far as I know. Yep. All right, yeah.
In the list of languages I could see in C++,
Yep.
do you know something about existing offline support for embedded systems?
Running gRPC in embedded systems. I don't know if it works, because someone was talking about running it on some IoT device, and it wasn't working for some reason because of the C++ implementation. Yeah, so as far as I know, it doesn't work yet. Yep. All right, so if there are no other questions, feel free to stop by for stickers and T-shirt if you want it. Thanks.